9.1. In this entire chapter 9, we will focus on quadratic equation, quadratic functions. So first we're going to look at quadratic equations, how to solve by a different technique other than just factoring. So in this 9.1, we're going to use the square root property to solve quadratic equations. So which type of quadratic equations can we apply the square root property? Here's a very important part. If you can rewrite a quadratic equations into this format, the expression square, the square term by itself on one side and a number on the other side, then I can use the square root property by square root it on both sides, and then that will give me expression is equal to plus or minus square root of k. So you have to remember to put plus or minus because we can get two solutions. Okay? So for example, I know that 2 to the second power is equal to 4, and negative 2 quantity to the second power is also 4. So when I solving x squared equal to 4, I should be able to get two answers. So when I use the square root property, I square root it on both sides. They should have plus or minus in the front. Otherwise, you will be missing one of the solutions. So, for example 1, can we apply the square root property on this quadratic equation? So the idea is try to cover up the square term. If the other terms on both sides of equation has no more variable, then we can use square root property. So to use square root property, first I need to isolate square term by itself. So I add 18 on both sides. That become 2y squared is equal to 98. Then I divide both sides by 2. So y squared is equal to 49. Now I isolate the square term by itself already, right, with no coefficients. Then I can use the square root property, saying that take the square root on both sides. So when you take the square root on both sides, don't forget to put plus or minus. So this will become square root of y squared is equal to square root of plus or minus square root of 49. So therefore y is equal to plus or minus 7, which I have two solutions, negative 7 and 7. So I got two real solutions. Continuing on the next example. So once again, when I isolate the square term by itself, I see I don't have any variable in other terms in both sides of equation. So that tells me I can use square root property. So to use square root property, first I isolate the square term by itself by subtracting 12 to both sides. Now I can apply the square root property, which is taking the square root on both sides plus or minus square root. So this will be c squared is equal to plus or minus negative 12. Square and square root cancels it out, so c is equal to. Now, if we didn't talk about 8.8, we will be saying that this equation has no real solution. It is true because the equation will end up in a complex solution. Because we talk about 8.8, starting from now on, our equations can have a real number solution or a complex number solution. So to continue simplifying this, it will become plus or minus square root of 4 times 3i. That's how I look at it. Right? So this will become c is equal to plus or minus 2 square root of 3i. That will be my final answer, which in this case, I have two complex solutions, negative 2 square root of 3i and then positive 2 square root of 3i. So now you have to be careful that we have a complex solutions and then we have a real solution as well. Let's take a look at on the next example. So example 3, can we apply square root property? So as usual, if you cover up the square term by itself, if you don't have any more variable on any other terms on both sides of equations, then square root property is applicable. So isolating the square term by itself, so we add 2 to both sides, that'll give me 36. And then we divide both sides by 5, so 36 over 5. Applying the square root property, we take the square root on the left hand side and then right hand side. Don't forget the plus or minus sign. So r squared is equal to 36 over 5. Square root of r squared is r is equal to plus or minus. This I can write it as square root of 36 over square root of 5. So which we can simplify plus or minus 6 over square root of 5. Most of the textbook and a lot of multiple choice tests on a final exam, you will not see the radical number in the denominator. So therefore, it's always a good idea to rationalize your final answer. So in this case, we're going to rationalize our final answer, which means I need to multiply the top and the bottom by square root of 5. So this will become r is equal to plus or minus 6 over square root of 5. I multiply by square root of 5 top and bottom to rationalize it. So this will become r is equal to plus or minus 6 square root of 5 over square root of 5 times square root of 5 is square root of 25, which is equal to 5. So now I got my answer, which is negative 6 square root of 5 over 5, and then positive 6 square root of 5 over 5. And that will be my final answer. Looking at in the next example, this time my square term, the base is a binomial, but the way that we consider is the same thing. If I cover up the square term, if there is no other variable terms, then we can use the square root property. So this is already isolated the square term by itself for you. I can use the square root property right away. So this will become 3r plus 4 square is equal to plus or minus square root of negative 8. On the left hand side, square and square root, they cancel it out, so it will left with 3r plus 4 is equal to plus or minus. When I simplify this, that will become 2 square root of 2i. Now, we're going to continue solving this. So first, we're going to subtract 4 to both sides. Let me show you how you should be writing. Because we ended up in complex numbers, so we need to write it in standard form, which is a real part and then imaginary part. So therefore, when I subtract 4, this is how I'm going to write it down. Minus 4 plus or minus 2 square root of 2i. So I'll put it into standard form. And then finally, I'm going to divide both sides by 3. So this is how I'm going to divide it. Divide the real part by 3, plus or minus divide the imaginary part by 3. And then right away, it will give me my final answer in standard form. I cannot reduce it, so therefore, my final answer will be negative 4 over 3 minus 2 square root of 2 over 3i. And then the other one is negative 4 over 3 plus 2 square root of 2 over 3i, which is both of my answer. Last example. So, as usual, if I cover up my square term, I don't see any variable on the other terms on both sides. So therefore, the square root property is applicable. So now I'm going to start my process of isolating the square term by itself. So first we add 8 to both sides. So this will become 96. And then we divide both sides by 3. So it will be b plus 3 over square. So that will be 332. Now we take the square root on both sides. So plus or minus square root. So b plus 3 square is equal to 32. So square and square root, they cancel out, so it'll be b plus 3 is equal to plus or minus 32 is 16 times 2. So there will be 4 square root of 2. So hopefully at this point, you're simplifying the square root is a lot smoother and then, going well. So finally, to solve for b, we subtract both sides by 3, which is going to become negative 3 plus or minus 4 square root of 2. So this gives us two answers, negative 3 minus 4 square root of 2 and negative 3 plus 4 square root of 2. And this concludes the sections.